In this video, we're going to talk about instantaneous slope, which is the MTAN formula in your book. So what this is basically imagine that you have a curve, and I'm just going to draw any curve, and you wanted to find the instantaneous slope at x, and of course the y value there is f of x. So the idea being that you could go a little ways out to a point A, and it could be out to the right or out to the left. We could go back this way. If we do it back to the left, it'll match our formula in the book a little bit better. So this is A, and this would be A, f of A. Excellent. Okay, so if we want to find the slope between these 2 points, as you can see when I connect the dots, that straight line and that curve line don't exactly match. However, the slope, the average slope between those 2 spots, would be the difference in the y's over the difference in the x's. Okay, nothing too magical. Now here's the idea though. As I take that A and I move it closer and closer, or as I take this X and move it closer and closer, so as I move this closer and closer and closer, so if I chose an X right there, you could see that that line segment and the curve are going to look nearly identical. So what they do is the MTAN formula becomes upgraded when I throw a limit in front. So the limit as x approaches A means that I'm going to get the instantaneous slope right there. Now this reason why they call it MTAN is the instantaneous slope is the same thing as the slope of the tangent line to the curve at that spot. Okay, so what we would get here when I do this is I would get the slope of f of x at x is A. So that's what I'm going to get there, which is also the slope of the tangent line. All right, cool. Now, what I'm going to go ahead and do is I'm going to go ahead and use this formula twice. In this video, I'm going to keep going, and I'm going to use it with the function f of x equals x squared plus 3 at the point 1, 4. So in your homework, they're going to give you a function, and they're going to give you a point. So this point is A and f of A. So what they'd like me to do is to plug it into the tangent formula with the limit. And I'm going to plug in f of x minus f of A all over x minus A. So this is f of x minus f of A all over x minus A. Okay, now what's A? 1. So let's go over here and fix that. Okay, so when I do this, I should have all x's or numbers. That's it, x's or numbers. Okay, now, if I were to plug in x is 1 right now, I'd get 1 plus 3 is 4, minus 4 is 0 over 0. Wah, wah. So what's going to happen every single time you do these problems is that if you actually plug this in, you're going to get 0 over 0. So we have to do some algebra, guys. So let's see what I've got here. When I look at that top, I'm going to get x squared minus 1, right? Plus 3 minus 4 is minus 1, all over x minus 1. Okay. So when we first started doing algebra problems with limits, we would factor. So the top is a difference of squares. So I could write that as the limit as x approaches 1 of x minus 1 times x plus 1 all over x minus 1. Okay, now that crosses off, and once that denominator disappears, guess what happens? If I plug in 1 now, I'm going to get an answer. If I plugged 1 up here, I'd still get 0 over 0. But if I plug in 1 down here, I get 1 plus 1 is 2. All right, that's my answer. Woohoo! So what is this? When I'm looking at the curve x squared plus 3 at the point 1, 4, what's happening is that I have an instantaneous slope equal to 2 at that spot. All right, there's going to be another example in the next video that has a fraction, a rational function. All right, good luck.